Greetings to all of you. I am Akshay Pawar and I welcome you to the latest webinar of TAIym Webinar Series. Today we have a very special speaker among us, Diwakar Velu. Some of you must know him, as our tunneling world is rather small for his distinguished career, and his career graph and achievements are an inspiration to all the young engineers. Diwakar is currently working as a deputy project manager with LTS Singapore. He has a master's in project management from National University of Singapore, and he also has an advanced master's in tunneling and tunnel boring machine from University of Turin, Italy. He was one of the finalists for Young Tunneler Award of ITA 2019, and he is also an active member of Tunneling and Underground Construction Society Singapore. Professionally, in the recent past, he has successfully managed two key projects, namely Contract 933, which is Bandamere Station on DTL3 in Singapore, which consisted of tunneling under pre-war shop houses and under the busy Jalan Besar Road, and also for Contract T222, which is Outram Park Station, where the tunnels were successfully mined parallel to an existing operational tunnel. So pretty challenging projects. Currently, he's also involved in ongoing Circle Line project, which involves about 200-meter pipe-roof mine excavation for future subways using micro TBMs, so which is also a very sensitive sort of projects. And he is also a part of the team which is planning for future cross island line. His talk will be mainly about tunneling experiences from Singapore. What are the challenges he faced there, and also the typical case studies. Now I will hand it over to Diwakar. Before that, I just want to inform all the participants that whatever questions you have, whatever queries you have, you can select the raise your hand option from the menu bar in your team screen, and in the end we will select all the people who have raised their hand and we will take your question one by one. So Diwakar, I again welcome you on behalf of TAIym and thank you so much for sparing your time and sharing your experience with all the young engineers. We really appreciate it. Now I hand it over to Diwakar. Diwakar, please take it from here.
Yeah, thank you, Akshay, and the members of TAIym for inviting me. It's a pleasure to be here and share my experience. I'll quickly open my slides. Okay, basically I'll be sharing some of my Singapore tunneling experience. I've been in Singapore for past 7 years, and as what Akshay mentioned, I've been a part of these 2 critical projects in Singapore. So I'll be sharing some of the experiences from those 2 projects because I find those 2 projects to be keen in terms of Indian perspective because it's based on a city-oriented location where there are a lot of challenges that you have to face and plan before you execute the tunneling works. I'll just skip my introduction because I think Akshay has given a very good introduction. So I've been for 8 years over in Singapore, and I've completed my BE in India and master's in Singapore as well as a master's in Turin. So that's a basic thing. So I'll just go over to the next slide. So the contents which I will be sharing today is I'll just give an overview of the Singapore Land Transport Authority and what we do. What is the Singapore geology, because you need to understand what geology we have here and what are the challenges here. Then I'll start with 2 case studies. One is what Akshay mentioned, going under a parallel existing line, and another is tunneling under old shop houses which don't have any as-built foundations, and we have to look at the challenges going under such sensitive buildings. Because in Singapore, they treat those kind of buildings as historical buildings, and they don't want to, disturb the architectural effect or, don't damage those buildings. So it was a very challenging project. So I'll touch some ideas on how we manage those projects. In that, I'll be touching on what are the design we have taken, what are the mitigations, and how we tunneled under, and some of the instrumentations which helped us manage those projects. I'll share those results. So you can understand how the ground behaves for this kind of tunneling works in Singapore context. I'll just conclude later on whatever we have seen over. So basically, I think this many people would have seen. This is Singapore's typical underground, map. So we have about not 50 meters below. Until there, we have about tunneling. I think last week even Senthil would have shared the same thing. So basically, I am working more towards the metro lines, which are somewhere here. So we work around 30 to 20 meters here, and most of the metro lines are in that area. The deepest is the Singapore power grid tunnels, and in between those are the deep tunnel sewerage systems. So basically, this is a typical cross section, and whatever projects related to each of the authority, they mine under this kind of depth. So we don't, come in contact with each other, and we have enough of cover for the future lines actually. So typically, this is a cross section. If you can see here, this is for the utilities, this is for the road tunnels, this is for metro, and here is for the power grid tunnels actually. Going to the future, what we can expect in Singapore, I just wanted to share. We are expecting about 360 kilometers of metro lines. So I am part of those lines. We have 2 new lines coming up, and also we have 3 extensions ongoing actually. So Singapore is in a mindset that in future, every people within a 10-minute walk should reach to a bus station or an MRT. So they have a very big plan ahead of us. And so we have a lot of job here, and it's going to be quite challenging for us here. So I just wanted to share how Singapore is being prepared for future population and future developments going on to be actually. This is a typical Singapore map. If you can see here, these are the existing Singapore metro lines. So I have been a part of these 4 contracts which is being shown here. These are all the contracts which were there before I came in. So I was a part of Downtown Line project. This was started in around 5 years back, and we completed very recently. And this is the ongoing Thomson line, which we completed now. And this is being extended further to the Singapore Changi Airport here. And there's going to be another small parallel line which is going to connect to the new terminal coming up here, which is in construction now. We have another future cross island line which will run through the parallel of Singapore across from the east to west. Then we have another project going to connect the perimeter of the Singapore that is in planning stage, which I am also a part involved. And now currently we are closing a loop of circle line. This is a circle line over here, and we are closing the loop. Earlier we didn't have a circle, we had a kind of inverted U, but now we are closing it. So in future there'll be a circle line here actually. Then we have few other metro lines which are planned, but these are mostly overhead metros because this part of Singapore is mostly in very hard rock. So they don't want to tunnel underneath. So, and we have enough of space there to do overhead metro lines. Majority of the tunneling works are here. And this is the major CBD district, which is very critical. And I've been, most of the projects of mine are in those kind of areas actually. As I mentioned, this is a Singapore geology. So I'll quickly run through the geology for your information. So you can see here, this is pretty hard rock over here. Here we get around weathered Jurong formation. We call it as weathered rock. Here is a kind of Kalang formation. We call it as marine clay. It's a very soft clay. You can mine very good. This is more of a stiff clay. We call it OA. So this is a very good ground to mine in for Singapore. If you get a project here, we'll be the happiest person to do mining here. Kalang, and this is the central business district, which is mostly a reclaimed land. So this is a very challenging location to do project because it's very, very soft, and majority of projects being done here have to do a lot of ground improvement before we can do any projects to be started over there. So I'll just give you an overview of how the geology looks in Singapore. So you can see this is OA, is more like a stiff clay, is easy to mine, but it's little abrasive. So you must be very careful with your cutter head selection and tools. You must monitor very carefully. Though it's good to mine, you get a lot of abrasion in your cutter wares. This is Kalang formation, is a very soft clay, and you can just sweep in and go. You can hit about 15 rings per day actually. This is a Jurong formation, so it's kind of weathered rock. So it is still good to mine, but you cannot get that much of penetration rate. So you have to carefully mine, because sometimes it's weathered, sometimes it's good. So you have to be very careful. So mainly in these three kind of geology, we choose EPB machines. Coming to the next part of the geology is this Bukitima granite and weathered and full face Bukitima granite rocks. So these are part of around the north side of Singapore. So these are very good rocks, and mostly we choose slurry machine for this kind of projects actually. So you will now have a better idea of what geology is in Singapore. These are the 5 main geologies which is more predominant in Singapore, and where you have to design for the tunnels in this kind of ground. The last one is the reclaimed land. So this is how Singapore's reclamation, the central business district, was looking very long back in the 90s. And now it is what you see, the typical CBD district of Singapore. So this whole area was a swamp, and then they had to, fully reclaim the whole land. So majority of the offices are here, and majority of the interchange of all the lines are here. So this is a very, very challenging location to tunnel and do station constructions over here. Not only tunnels, even the station deep excavation is very difficult and challenging in this kind of ground in Singapore. And now they have already got a lot of projects done, and we have quite a lot of experience. Even recently, we have done ground freezing also in one of the stations. So it's been a quite challenging and experiencing projects being held at the CBD districts of Singapore. So to give you a typical history of tunneling in Singapore, so you can see totally we have so many metro lines, and we have got about 173 TBMs, and we have mined about 229 kilometers till date. So now we are going to reach about 380 in future. So we have, Singapore has till date used about 173 TBMs, and now currently the CCL6 and Nelly projects are ongoing actually. We have used this kind of 4 machines: EPB, slurry, open phase, as well as rectangular TBMs, which many people would have seen because it's been talking worldwide and was one of the IDA finalist winners of 2 years back, I guess. Okay, coming to the case studies here. So I'll be mostly touching on the Thompson Line project where I worked, and I was a part of the civil team 4 because I was working for Outram Park Station over here, which is an interchange of existing 2 lines, one coming from the north and one coming from the east. So this will be serving as an interchange station in future. We have completed that. There we had quite a challenge where we had to mine under an existing live line. So I'll share about that in the coming slides. So as I told, north part of Singapore is mostly hard rock. So we use slurry machines. So these are some of the cutter heads, if you can see, that have been used in the north part of Singapore where we started with the Thompson line. So mostly slurry machines over there. And coming at the bottom where we are entering into the soft ground reclamation land, we are Jurong Formation, we chose EPB machines. So I'll be talking about my project, which is T222, done by Korean contractor TAIym, and they successfully completed, and we're going to open it soon, maybe in a year or time, depending on Corona's evolvement actually. So you can see roughly how the opening ratios of cutter head have been, spaced compared to the rocky conditions and soft clay. Usually you need a better opening in soft clay so that you can get a better penetration and mining actually. So this is the civil team 4, which I was a part. This is a CBD district, and we had 5 projects over here, and I was a part of this Outram Park station over here where we had to mine 1 TBM along to Havelock and 1 towards Maxwell, the station over here. So that will be the project and the case study which we'll be looking into in the coming slides. So this is a typical layout of the station which we are going to study. I think even Senthil had shared earlier, because he was also a part of the project. So he was talking about a mine tunnel in his previous session. Now I'll be talking about the bore tunnel stretches in this particular station. So as you can see, this is a very congested area over here. Here are very pretty small shop houses over here, where we had to go parallel and stack and dock into the station over here. And the other 2 tunnels, this is a green, is an already existing line. This is the oldest line in Singapore, And you can see we are going parallelly under this line, and we are curving into the new station, that is Havelock Station here. So this particular stretch will be an undercrossing of parallelly under the existing line over here. So I'll be talking in detail about those areas and some of the stakeholders, because stakeholder in Singapore is very important. They are the key. We cannot avoid them. Here we had to deal with a lot of stakeholders. One was the operator themselves who were operating the MRT above. And here we have a Singapore General Hospital. We have a quite lot of people. This is a major hospital in Singapore over here. And these are pretty old shop houses. People who own shop houses are very richest people in Singapore. So you have to be very careful with the stakeholders when you're mining over here as well. And here we have some hotels, big hotels, that also we had to take into care, because we are mining very close to the buildings, and any sensitive structures we need to keep them informed actually. This is a station. So what I wanted to share here is basically how tight the shaft is, because we are in a CBD district, and generally in Singapore there's a big issue with the space crunch situations. So we are having problems of having a bigger shaft, or we cannot have the luxury of launching a TBM very finally. So we have to launch in very small locations, and also with we have to go under immediately when you come out of this. Hello.
Yeah, you are audible, sir. Somebody has put on his mic, so I think you can continue now.
Okay. So as I was talking, in Singapore, the space crunch is the biggest issue. So we had to launch in very tight situations. So as you can see here, this is a typical layout of our site. And you can see that we have to launch a machine exactly under the road immediately when we come out. And in this case, we had an issue where we had to tear down a part of this building because there was a pile which was obstructing the tunnel. So we had to take down the pile before we had to mine through. So this is the Pearl Center, and we are going to mine through the pile. So we had to take out the pile, so we don't have to stop the machine, take out these piles to the cutter head actually. So you can see we had to do quite a demolition to this building before we could extract the piles, and then we could start mining forward actually. So this was one of the challenges when you have to mine in a very sensitive business district locations actually. So we have to take care of this kind of thing. Imagine getting this pile into your cutter head, you will lose a lot of time. So this is a major challenge in Singapore, because there are a lot of piles you have to take into account, and then design, also pre-design and take this remove this kind of things. So you must be prepared and plan very well to study the as-built drawings of these existing structures. As I told, the critical challenge of our project is going under the EWL line. As you can see, as you can see, we are going under the EWL line, and the closest distance is about 2 meter, and farthest is about 8 meters. So we will be going at a gradient from 2 meter to 8 meter when we launch from the station. And in addition, we will be going through between the piles of a famous hotel called Link Hotel, and also another hotel called as Wang's Hotel. So you can see here, this is our new line, and we'll be going in between the two piles. And here we have the CT flyover, and we have to go below the flyover. And here we had another hotel, which was a very old hotel, 4-story hotel, and we had to go very close to the piles of this hotel also. And in all these three sections, we are going under the EWL line. So we were going under the live MRT. That was a really challenging thing, because we are putting a lot of people on risk above, and we had to take a lot of care to manage this project. So I'll just quickly show what is the geology. I have already shown before. So here we term the geology in terms of S3, S4. Each Jurong formation and the granite we divide into further to better assess and plan for the tunneling parameters. So as you can see here, this is mostly a weathered Jurong formation when we are going under the EWL line, and we are as soon as we end this stretch, when we go to the next station, a short location, we are quickly diverging into a very hard granite. So this was another challenging thing. So in Singapore, that is a very important thing to note. Not unlike in other countries, you will have a uniform ground over your tunneling length. Here we have this problem of going through mixed phases as and when you are in certain locations. So that challenge is something very difficult to be managed, and we have to carefully assess those kind of things. So that here, as you can see, from a full weathered rock, you're going to hard granite, full face granite. So you have to plan very well when you're mining in that location, so that your tools are not damaged and you don't get your TBM stuck there. So as I told, I'll just quickly show you the cross section. So as we come through the station, we are going under a box tunnel, which is about 164 meters of length. Then it's a box tunnel, which is a crossover above us. Then we have about 312 meter of bore tunnel stretch, where we'll be going under the existing EWL tunnels, bore tunnels. So box tunnel, the risk is a little bit lesser, but when you go under the bore tunnel, it's quite challenging because you cannot allow the tunnel to be moved to a certain limit, which has been calculated through the design analysis. So that will be the challenging part in this project. As you can see, majority of our work is going under this weathered Jurong formation. And one key thing to note is Singapore is that you have a lot of fill layer on top of this thing. So even if the EWL line, the existing line is in a good ground, there is also a problem to tackle the surface settlement. So that is another challenge which we had to face in this project, which I can show in the later slides. What are the mitigation measures we took? Some of them we did additional soil investigations, because we cannot do exactly under the above the tunnel, because there's an existing tunnel. So we had to do additional investigation nearby to understand exactly what is the geology. And for critical structures, we had to do soil some seismic investigations to ensure that the pile length in the asphalt is same as what it is, or if it's differing, then we have to make sure it is not there, so we don't encounter an obstruction and get some delay in the project. And also we have this habit of when we undercross, before crossing and after crossing, we do a cut ahead intervention, so that we can undercross the structure without any stoppages. If you're going continuously, then you find something is your tool is getting damaged, then you stop under a structure, it's a big risk. So we have that culture where we have to we ask the contractors to stop, check the tools, then we go under the any buildings which we undercross. So that's what we followed here also. And we rely mostly on real-time instrumentation monitoring. So for all the structures which are critical, we put up real time, so we get live feed of what is the movements within the structures actually. Design aspects. The design was done is a built only contract, so we had a pre-design done by Arab, and the contractors QPD also. In this case was GC Singapore. So here the key thing to note is that we have to consider the tunnel above us. So they took 10 limit states, which I think already Senthil has shared in the previous session. Mostly these 10 limit states have been taken, and they have been considered for the analysis part. So in this, the first 5 are basically on the tunnel structure itself. So, and the remaining 5 are on the track gauge itself. We should note that even if the tunnel moves and the gauge, you have to interrelate and see how much is the movement. It is not necessarily that the track moves means that the tunnel is moving. So there was this difficulty which we had to assess very carefully, because the limits, as you can see, allowed is 15 mm. Some of the locations where the twist, they only allowed 1.5 mm of twist that can be allowed for the operating tunnels actually. So it was quite challenging to get a relation between the two, because even the movement of the trains itself were causing some twist and changes to the gauge. So it was a challenging to manage between the operator and our contractor to coordinate this analysis of the instrumentation readings actually. This was as I told, we were going under a very old tunnel in Singapore. So you can see the structure, how it is. And based on analysis, the consultant had given us that the allowable limit is 15 mm. And in some locations, they even told that because the structure is very bad, the settlements could be even more. So we had a very challenging project ahead of us. So we had to control the parameters very well. So this is a basic design that was done for the EWL tunnels actually. And how do we manage the settlements? We needed a very robust instrumentation regime inside the tunnels. So you can see the amount of instruments we installed. We installed about 5,000 prisms. And we had EL beams to understand the twist. We had also the tilt meters within the prisms. And also we wanted to understand the vibrations that's coming. So we also installed some vibrometers. So this is a basic skeleton of how the instrumentation was fixed within the box tunnel and the bore tunnel. So this is a box tunnel and this is a bore tunnel. So we had EL beams here and tilt meters and prisms, around 5 prisms over here. As earlier I showed the 10 limit states. All these 10 limit states, we use these instruments to monitor the movement and according to design to monitor and see whether we are within the range of good mining actually. So this is a typical scheme, because every night we had to go in and check whether everything is good. Usually the tunnels are not operated between 12 to 4. So we go every night between 12 to 4 to have a look at the whole stretch where we are under the particular stretch. We go and take a good look at the structure and ensure we don't, the next day operation is not hindered or something like that. So we have to pre-alert the stakeholders actually. So that was a quite challenging thing to manage when we were doing this project. This is a typical instrumentation layout. As you can see in Singapore, we generally do a influence analysis, so-called 25 meters ahead of the TBM and 50 meters behind the TBM. So we instrumentation update. All this instrumentation within the TBM influence zone, we get the readings on a daily basis, and the remaining ones we take it on an alternate basis. So this is the scheme which we use, because we find that this particular zone is a key zone based on previous project experiences, that the TBM's influence is at this particular area, and it has been proven also. So we follow that estimate to monitor on a daily basis. And this is a typical array drawing where you can see some settlement markers, piezometers, inclinometers, and extensometers that have been put across. So it's a typical array. You can see the arrays over here, and each array will be having this set of instruments over here, and we will be getting a daily instrumentation analysis as what you have seen here. We get that, and based on the movements, we take decisions on site whether to stop or review or what to do actually on the next basis. One more key thing apart from the usual project when you're going under the live line is to measure the track. So what we use the track gauge. So this is a small instrument that we put on the existing rail every night, and we run it over the 350 meters which we mine through, and we get the values. So we compare it on before and after we have crossed a certain stretch of the tunnel, and we see whether we have moved very heavily or not. Are we within the limits of what the operator has given us? So we have to do a very close coordination with the existing operator to understand what is the limit and whether it is good to mine, good to allow operations in the next day based on our TBM being mined under. So this is one of the key things which we had to do on a daily basis till we had undercross the whole existing live tunnel actually. So we put up a flow chart where certain things on the twist and certain levels when we breach, then we either reduce the speed or what, that is decided by the operator depending on his assessment. So we had to do a very close coordination with the operators to make sure we are in a good shape and not affecting the operations on the next day actually. And the others, thing I mentioned is the stakeholders. So we have also a few other stakeholders that are around the tunneling stretch. One of them are the hotel, so we had to engage them. Any complaints, we have to go and talk to them, make them comfortable, because they have all the rights to stop the job if we are not answering them properly. So Singapore is very committed to stakeholders, so we do a very good stakeholder management. And as you can see here, this is a picture, because being an old tunnel, we also went to an extent to ensure all this fasteners are properly held, because even if the fasteners are not loose or something, the gauge readings would be different. Then it might make us an alert, which we will finally have to stop or review all the parameters again. So we went to an extent where we worked with the operators to ensure all the fasteners are replaced and put new, and so we can confidently mine under the tunnels without any problem, because the main thing is the train must not derail or something, because a big accident, you can imagine the fatality what will be happening. So we had to take extra precautions. In the other thing is we also have a project information center set up at each project, so that the people can come and hear and see what is the project, and we give them all the details what they ask, and make them aware of what is going to be happening. We engage them on a monthly basis. So that is how we keep the stakeholders engaged, because they are one of the key things for a project to be run. And in terms of a monitoring regime, though we have alert levels and work suspension levels like usually we have, here we set up an alert level and work suspension level internally, so where we can internally coordinate between the teams within us. Maybe the qualified person from design, supervision, everybody come and assess the whole thing before we touch the work suspension level, because once we touch the work suspension level, our TBMs, no matter where they are, we have to stop, make it safe, and then only we can mine. So it is a very key thing we have to look out when we are mining, and this instrumentation results are being monitored actually. So we had to set our own internal levels before we could alert anybody else. So that is what you can see in this graph actually. Going on to the TBM design, so that was another challenging, because as I told, we had weathered rock and full face granite. So you cannot allow a full face boulder to come inside the TBM. So we introduced the concept of Grizzly Bars. These are small kind of braces, as you can see, which limits the size of the boulders that can come inside the cutter head, so that you don't break or you don't damage your screw conveyors. So here we chose two types. One is bolted and welded. So, for example, when we are going under a weathered rock and you don't need, you're reducing an opening ratio, we generally unbolt the Grizzly Bars and give a better opening ratio. But when we are going under full face rock, then we put it back in the cutter head intervention, so that you don't allow big chunks of boulders to come inside and clog your opening into the screw conveyor. And in Singapore, the other problem is that your TBMs, we cannot lift it once you finish your mining. Generally, we dismantle and bring it back through the tunnel. So because we don't have the facility of docking or receiving shaft or something like that, and at most of the situations, the stations wouldn't be excavated, so we will be reaching first, and the station would still be at the first 10 meters or something like that. So mostly our dismantling happens within the tunnel, which I'll share later to give understanding what I'm talking about. If I don't know how is it in India, because I've not heard that, but I'll just share how is it in Singapore. And another key factor we considered is, apart from the 6 earth pressure sensors which is in front of the TBM, we also installed 2 earth pressure sensors on the top, because we wanted to see if there is any rocks falling onto the TBM, or if we are grouting too much above the TBM, because we had the EWL tunnel on top. So we had to closely monitor the overcutting, how much we are doing, and whether there's any fall, because a fall of you generally overcut is about 20-30 mm. So 30 mm of settlement is quite a huge one actually when you're undercrossing certain sensitive structures. So we had to closely monitor, and these sensors were quite useful in terms of monitoring the ground above the TBM. Coming to the tunneling operations, you can see this is the geology which I already told. So here, this is the design phase pressure. So you can see the average phase pressure is here, and the yellow color is the target phase pressure, which is given by the design consultant that we need to maintain to mine through the this stretch of the tunnel. So you can see that we were always above the target phase pressure, ensured we are not below, and at the same time we were very careful that we don't heave the tunnel as well. So that this shows that we have done quite consistent mining throughout our project. This is for one tunnel I'm just showing as a reference. And this is a design consultant's impact assessment. So the predicted volume loss was somewhere around 0.5 to 0.7, and we were well within 1% of volume loss. You can see the blue dots, which are the volume loss actually happening here. So we were quite okay, and we were lucky that the ground was quite stable and we could manage the tunneling under the EWL without any issues. And coming to the Tbm excavation management, so we are very particular about how much of soil we are being excavated. So we always keep a 10% plus minus excavation volume, percentage that we can excavate. So we generally mine with the full chamber. We don't allow the contractor to mine with half chamber or something like that. So we ensure we don't go above 10% of excavation. Then we consider it as over excavation. We give them warnings as well. So we are very particular about the excavation limits. So as you can see along the TBM under the EWL line, we were well within the 10% margin, and we excavated quite well actually. And the next graph here you see is the grouting limits, because we have to fill the grout of the overcut. So we always ensure that the target grout, this is the green color, is the target grout that we have to pump in based on the overcut of the TBM. We always ensure that the contractor is plus 0.5 meter cube more than what we are targeting. So we were well within more than the target. So we ensure that we have properly grouted the whole thing, because later we don't want any void being there and then causing trouble in the future actually. So these are key parameters that we look out and we monitor on a daily basis to ensure we have done a good job actually there. So I can just give you a rough feel of how the ground varies from one stretch of this end to the other stretch here. Under the EWL line, we went through this kind of rocks. So managing this excavation based on the density which we used to calculate the excavation volume, it was quite challenging. So for every 5 rings or 10 rings, say, we usually do a site density check. Then we estimate that to ensure that we are well within the 10% range, because it keeps changing because of this kind of geological conditions that we encounter in the mixed phase of Singapore. The other challenging things are during tunneling, we do real-time monitoring. So we do 24 hours day, 3 times monitoring when we are tunneling under sensitive structures. And another thing which we usually keep is a 24-hour surface watchman. So when we are going under any critical structure, we keep a 24-hour watchman there who closely supervises it and informs any problems or situations, so we can quickly stop, alert the TBM operator. And also we have a standby grouting rig which moves along with the surface watchman, so we can quickly tackle any of cavity that has been formed actually. So this is a thing which we use for all sensitive buildings or sensitive undercrossings as a risk mitigation measure actually. And you can see this is operational parameters when we were undercrossing. So first TBM to mine was the TBM 3, and the second one was to go was TBM 4. So initially when we were undercrossing the tunnels, we didn't have a proper understanding. So it's a lesson learned what I'm going to show here. So when we were mining under the TBM 3, we had no clue what is the speed we can achieve in this kind of ground and what we have to look out for. So the contractor was trying to play with the cutter head speed to see at what level the speed is getting increased and we are getting a stable torque, so that we can mine at a stable torque. The most important thing is to get a stable torque and a better speed. So here you can see the contractor tried, and later they found that this was a perfect speed and cut rate rotation that could give us a better penetration rate, because both the tunnels were in the same ground. So you can see the next TBM, when we learned from the TBM 3, we implemented the same and we were achieving better penetration rates. So we were going at the start itself, we were going at 15 mm per minute. So we completed the second TBM, which was undercrossing as well, and at a quite faster time actually. So it's very important to study the parameters and implement it for the next bound of tunnels, so that you can do a better tunneling thing. So this is one example of how we manage the tunnels from the previous lessons learned actually. This is a quick summary of what is the ground we were in. So when we go for cartridge interventions, we take a sample of the ground and check the density as well. So this is some photos we took. We had a quite challenging, as I told, this is a full face rock. So you can see we had damaged the whole discs actually. So you can see the first TBM when we mined, we had to do about 18 interventions actually. But whereas after the second TBM, when we found out the better torque and better penetration rate, we actually reduced and we could get a better production rate actually. So this shows how effectively the lessons were learned and were implemented for the next bound of drive. So we reduced the CHA and we were able to complete it faster. The other challenging part of doing intervention below an existing line is also a thing which we had to look in the initial stages. So the design consultants had to look carefully, because lowering a face pressure is something very challenging to do when you are under certain sensitive buildings. So here the contractors and the design consultants were very particular that they don't lower and cause settlement. So we made a flow chart where we can lower in step by step, and we can see the water ingress and the movement on the tunnel, and based on that then we can go further down, go into free air, because you can see the amount of wear we had to go in frequent CHI. Imagine going in compressed air and doing a CHI, we will end up being under a live line for about 14 days or so. So we had to come up with the schedule, kind of flow chart that could allow us. And in order to be very careful and not impact the operations, we coordinated with the operators, and majority of the free air interventions we did it at the non-operational hours, means when 12 to 4, when the live lines are not in operations, we lowered the cut-head intervention. We would lower it to free air, and then we would go in and quickly change as many as tools. We can do it in that 4 hours of time. So you can imagine 18 CHIs being done in such a case is really a very challenging job, and it was like sleepless nights for most of us when we were going under this EWL line actually. And in addition, one more thing which we had to tackle was this fill layers on top. Though the EWL tunnels were not moving, when we lowered the face pressures, the water drawdown had caused surface settlements to increase as well. So we then planned to put up recharge wells. Though it was of little help, it helped to manage the settlements on the surface. So you can see here a typical example of a CHI when we did. The piezo's drop when you lower down your face pressure. You can see the prisms also within the live tunnel. You can see the prism going down slightly, and also you can see the amount of settlement happening on the surface that is above the EWL line. So we had, when you lower down your pressure, there was a impact on the surface also. So we had to manage all the, even the EWL line as well as the surface. So we use the recharge wells to pump in as much as water it can intake, because Jurong formation generally don't take water, but we try to put and we try to manage the situation. It helped to an extent actually, we can say that. And here I'll share some of the settlement analysis that happened during this particular undercrossing of the box tunnel. As I told, the box is a very rigid structure, so we didn't have much of settlements happening on the box tunnel. So it was quite stable. We were within ±5, and also the prisms did not move because it's a huge structure where the box is there. so it was not of major concern. Whereas the bore tunnel, you can see the surface above the bore tunnel, we had about 10-11 mm settlement, and the prisms moved by 5 mm at max. So that was the maximum settlement we noted in the prisms actually. So this is just to give you a feeling of how the instrumentation behaved while we undercrossed the whole tunnel actually. This one is a typical prism movement. So what I did is along the chain edge, we had about 300 or 400 prisms that were put across the parallel line. So we took a particular reading before the Tbms passed the tunnel. So you can see the prism, the structure was not moving much. But then halfway through the tunnel, we took another sample and we can see that the tunnel has swinged up and down, but not much between. It's a plus minus 2 mm with an error also. It could be an error of the gauge itself, but it was quite stable. And at the end of the tunnel also, we were quite okay. So we did cause certain movement about 3 to 4 mm, but it still is quite within the tolerable range which we were expected. So I can say that we did a good mining under this particular stretch of the ground actually. Okay, now I'll quickly jump on to the Tbm dismantling in Singapore. So what I wanted to share here is the other challenge where we have limited space and Tbms here cannot launch in full. So we generally do a launch shaft, then we mine the Tbm for a certain extent, then we lower the backup, and then we do a main drive launch. And the other problem is at the station side, usually we don't have access. So we come, stop behind the station, then the whole Tbm is dismantled, and again we relaunch for the other drive. So this is a typical scheme which you can see in Singapore's metro line. And this is also one of the reasons why they use many Tbms here, because they want to get finish the projects faster. So they quickly launch and then they finish actually. So you can see that so that the tunnel second phase works can quickly commence and they can be ready when the station is completed. So imagine dismantling a whole Tbm inside the tunnel and with such a small area that you can take out. I'll just give you a sample of how it looks from other projects. So you can see all surrounding condominiums and buildings, and we are lifting such huge structures. And usually we don't have space, so we don't have capacity cranes, so they do tandem lifting. Tandem lifting is something where you have two cranes trying to rotate the whole Tbm and lowering into such a tight shaft. So this is what you will find mostly in Singapore. You will not get the leisure of a very big shaft where you can have a room to have so much space. You have the most of the shafts here are basically 20 to 15 or maybe it's a 25 to 30 20 meters long shaft. That's what is you get in Singapore, because generally the shafts are backfilled again, so it's a waste of money to excavate a bigger shaft. And in Singapore, tunnels are launched first. So before a station commences, we generally do a launch shaft. So it is very important actually here. So how does Tbm being dismantled? I'll quickly run through. So these are the steps. So first we disconnect the backup gantries, pull out, we can remove the belt conveyor, we remove the erector, screw, a beam, motor, manlock, the cylinders, the intermediate shield, the drive unit, the front shield, and the cutter head. So this is the general scheme which is being used, and we follow the same so that we are careful when we remove the Tbm. So I'll just quickly run through how it looks in a section view. So as you see, the Tbms go docked behind the station wall. Then we start removing one by one. So here we are trying to remove the main drive and the screw. And here you can see the screw support being taken away and the screw being removed away. And here we take the main drive unit. So the beam is being extracted and sent out. We use the locomotive to transfer everything outside the tunnel. Imagine a 1 kilometer tunnel. That is also a bigger risk. You have to transport the whole big components through the built tunnel actually. So that's another challenging thing. And here you can see we are removing the man lock, followed by all the articulation jacks and the middle shield. So you have to remove all those in parts. Then we have the cutter head. So we come to the bulkhead and the cutter head. So as I told earlier, because we have to do this, our cutter heads are made into parts, so we can easily dismantle and you reassemble for the next drive actually. So finally, you can see after the main drive and the cutter head is done, and we remove the cutter head in parts and it goes out. So this is a typical view of the actual real view of what you're going to see when you're dismantling within a tunnel. So this is a screw coming out, the drive unit, the man lock, the articulation jacks. You can see the bulkhead over here, the screw conveyor opening, and here you can see the final cutter head being removed. This is half cutter head, and this is the bucket, the full face rock. Usually because when we dock, we have a grout block there, which is a slurry wall. So you can see a proper wall over there when we dock behind the station block actually. This is a comparison of how many days it takes for the whole process. So initial launching, we target, orange is the target, and I've compared with 4 drives which we did there. So you can see again a lesson learned over here. So the first 2 drives always takes longer time, but then after the people and the workforce get experience with how we do within the tunnel, they generally reduce the work. So we have these 4 setups. One is assembly, launching in short launch, then the main drive with the full backup, then the whole dismantling. So this cycle is again repeated when you launch for the next drive. So this is one of the major scope and challenge, risky work that we have to undergo when you're mining inside, and rather you take out the whole TBM as a block from the other side. It's much easier. The second case study is a short one. This is about going under the shop houses, war houses, so-called the architectural Singapore, which very old shop houses over there. So as you can see earlier, I touched upon mining in Jurong Formation. So here I will touch upon mining in OA and Kalang Formation here. So this is a station, is a stacked tunnel. We are going 700 meters in old alluvium, and we are going in 350 meters of Kalang. So this is a stiff clay, this is a soft clay. So we are doing a mixed phase, interchange at this location over here. So as you know, this is a very old shop houses. We had to do an extensive check on the as-built drawings. So our QPD and client, we sat together, and then we got all the as-built. We found out which has as-built details, which do not have, and we demarcated, and we asked the contractors on board to go and carry out their own investigations to ensure that this foundation or what type it is, so that we can properly assess the settlements when they go. The biggest challenge in these shop houses was that certain buildings were in good foundation, but there was a 5-foot walkway in front of these buildings. Those were not in a foundation, so that was a challenging, because those were settling more than the buildings itself, causing a crack in the in the walkways. So this is what I was telling. So you can see the building over here, and this is the walkway. So these buildings were sitting in foundations, whereas this were not sitting in foundation. So you can imagine if this settled down, there's a crack over here. So we had to be very careful on how we had to manage this. So we introduced active props. So they put up props over here, and 1 month before, and we jacked it up and make sure that it's intact. And we also installed strain gauges over there, so that we could closely monitor the strain coming onto the building. Then we can ask a guy to go and look into, and then assess based on how it is actually. So this is how the props were put up. So you can see the whole alignment, we had props put up like that for the 5-foot walkway, where the building and the walkway is here. This is a typical condition of the buildings that were there. You can see the cracks already. There were so many cracks on the whole buildings, and we had to put more crack meters. So we did an extensive pre-condition survey, where we had to go take photos of inside, outside the whole building, and then the QPD did an assessment of what we have to do and how the monitoring regime had to be. So this is the shop house you can see here. You can see the props being put up, and also we had extensive tilt meters also put across, so that we can monitor the tilt, how is it tilting based on the 5-foot walkway and the building itself, because that was the riskiest and sensitive area over there actually. Another thing we had to take care when we are going under the soft clay was to ensure because the soft clay of Kalang, generally when you mine through, you squeeze in, then it comes and locks the TBM actually because it's very soft. So we had to ensure that the overcut that is being done is not squeezed in, so that we don't cause a consolidation settlement at the later part. Maybe the settlement will happen later. So we had grout ports along the TBM, and we used to pump bentonite along the shield, so that the bentonite is acting as a medium between the overcut till the backfill grout is being compensated by the overcut, so that the soil is not displaced from its original position, causing any further settlements actually. So we had about 24 ports around the TBM, then 12 over here and 12 over here, and they were pumping bentonite at all times to when we were mining through the soft clay actually. You can see the phase pressure. In OA, we were mining at about 3 bar. We were about 25 to 30 meters below. So you can experience that 3 bar is the pressure. And you can see when we are going into the Kalang, we went up to 4.5 bar. So you can imagine how soft the ground is. So if you lower the pressure, then your volume loss is going to be very heavy actually. So you can see in OA, our volume loss was very well within 0.5%. As soon as we entered Kalang, which is a soft clay, it went up to 2.5%. So it was showing a very immediate settlements. So we have to manage the Kalang formation also when you're mining, especially in the speed and penetration rates. So you can see in OA, as I told before, is also abrasive. So we had to do quite a lot of CHI to ensure the tools are in good shape. So as I told, when we are doing critical undercrossing, we do a quick CHI. So we stop every 45 rings, check if it's good, we close one day, then we start mining. So that's why we have quite less production, and average production is also quite less in terms of OA. But in Kalang, you can see is being soft is very good. At the same time, if you mine too fast also in Kalang, your volume loss becomes more. So you have to manage how you mine in this soft clay in Singapore actually. So I'll just quickly share some of the instrumentation analysis. So I'll just typically take an example here. We have certain buildings along a road, and this is in OA. As I told, we had to stop here for quite a long time because here is where the TBM was stopped, and we put up the whole backup and we launched in main drive. So you can see the typical settlement graph in OA when both the TBMs came in and moved out. You can see is more stable. So the ground is very stiff, so it can stand on its own. So OA is a very good ground to mine in Singapore actually. So here also you can see another graph of another building marker, which is showing quite stable readings even after being stopped for say 45 days to 60 days to convert the whole TBM before we could launch actually. For Kalang, as I told in the later part of the tunnel, you would have noted that we are transiting from OA to Kalang, so it's a mixed phase. So you can see here, this is the transition zone at certain ring level. You can see how the settlement has dropped. So we had about 15 mm drop immediately without doing anything. We didn't cock up or do anything, but the ground has settled. That is the design of the design consideration of Kalang formation, that it will cost about 2 to 3% of volume loss. So that's how soft it is. So we have to manage well when you are mining, especially with buildings on top. So if there is no buildings, you're okay. But if you have buildings, you have to make sure that they are also in good shape. So that is a key factor when you're mining in Kalang and with buildings on top. And another thing here is this also causes consolidation settlement. So we cannot stop monitoring. Maybe we have to monitor for quite longer time to ensure the thing is stable. That is one challenge we noted when we were mining Kalang formations actually. So one interference which we got from the TBM excavations is that, like what I said before, 25 meters ahead and 50 meters behind the TBM. So you can see that when about 20 to 30 meters before a particular array we uncrossed, you can see the settlement starting to come. So we can say roughly 3D, 4D ahead of ahead of your TBM, you can start to understand the instruments are reacting for your TBMs that is coming with the phase pressure over there. Similarly, after your TBMs have crossed a certain instrumentation, you can note that until about 50 meters or so, you still have some settlements coming. So that's why we say that we have to closely monitor 25 meters and 50 meters behind the TBM. So till we are satisfied that the instruments have not going down further. If they are going down, we have to go and quickly open up the segments and start, open up means drill through the segments and do secondary grouting to ensure we stabilize the instrumentation reading. So that is how we mitigate the settlements in Singapore actually. So coming to the conclusion, so as I told, when you're mining through critical structures, you have to understand the whole structural conditions impact both to the surface and also to the in between whatever the piles or tunnels are there. You have to understand both, and you have to manage the tunneling works over there. Now we are also considering to put up strain and stress load cells to understand, because we are going to undercross a few tunnels in future, and we want to put this also and check how we can manage from the results which we get. And when we are doing undercrossings, we must be effectively coordinating. So one good thing to manage stakeholder is doing a precondition, very extensive precondition, so that we know what is the condition and we can design based on that, so that if anything happens also we can come back and relook, and then we can effectively coordinate to understand how we can improve. Like in the case we went and replaced the fastener, so that it was a better thing, so we coordinated very well. Now in future, for live undercrossings, we are asking the operators within the train to install certain cameras and laser units that can automatically measure the twist and gauge, so we don't have to run these instruments inside the tunnel. So we are directly looking at that, so we have a real-time track measurements which we are considering for future undercrossings. Then for the tunnel operations, we are looking at 50-meter influence of monitoring, which I told already. And when we are going in mixed phase, we are looking at the penetration rates. So it's always because imagine you're going in a mixed phase condition. When you're going to enter something like this, your majority is in soft rock, but then you will not know that you're fully entering a full phase until you go halfway. By the time you would have damaged half of your cutter tool. So it's always better that when you're transiting in a mixed phase, lower your penetration rate, mine slowly. Then once you find you're better, you're really gone into a bad ground, then you can assess and then mine. That will help you save a lot of cutter head interventions. And another thing is very important is detailed instrumentations. So we had a very extensive instrumentation which helped us. One thing we would like to look in future is putting water standpipes. So we didn't have that here, so we couldn't assess how the water level was behaving when we were lowering the cutter head interventions. So we were depending on the inflow or the seeping coming into the cutter face to measure. So we are looking at putting water standpipes, and also the frequency of monitoring. And instead of we are also seeing the EL beams being put parallel. It will be better to put it in transverse location when you're mining parallel, so you have a better understanding also. So these are something which we are looking in future to better the monitoring aspects of the tunneling works. And to conclude, now we are looking into innovations and other things. So I want to touch a last slide on innovations. So Singapore of late, we are looking at a lot of innovative technologies, how we can improve, the productivity and efficiency of the workforce. One of the things we considered, which I wanted to share, was, when we break stop, as I was explaining, the TBM had to be dismantled. So this shield of the TBM is left over there. So afterwards, this particular stretch, we have to do a manual casting. Means we have to do a manual shuttering, then we have to tie rebars, and then you have to cast the whole thing. Always the best thing is you break into the shaft, so you have the rings fully built, so you don't have to do this manual casting. And this manual casting is something very challenging because it is a potential leaking point for water to come in. So in Singapore, they also tried a new technology where we use the lorry fitted with the erector, which was able to do tunnel segmental lining after the TBM was removed. Then we completed the whole segmental lining till the station. So that was one approach. So here you don't have to put labor, and the intact joint is good. You can do secondary grouting later on. So it was one of the good solution by one of the contractors. Other thing is in EPB, rather than using the soil coming out, one of the contractor proposed to use a pumping system. So they converted the slurry coming in the EPB into muck, and then they directly pumped it into the slurry tank, muck tank on top, so that it can be flushed. One of the challenging thing here was how do we manage the excavation, because when you add it when you add and make it into a slurry, it is very difficult to estimate how much of volume you have excavated. But this is still we are studying how to do. But this was one of the solution which we have also tried and tested. We tested it in ground, which is not so risky, means it with no major surface structures actually. Another situation is we also looked at not dismantling the whole TBM and again relaunching. One of the contractor came up with a U-turn, so they put up a U-turn table on between in center of the shaft, and then they rotated the whole TBM and relaunched it with the backup. So this whole thing was done in a matter of week or so. Whereas when we compare, when you take out, put it in another area, then you launch, you don't have to use a gantry crane. Surface equipment is not needed here, because generally a receiving shaft you don't have a crane actually. So those kind of things actually saved a lot of time. So I think we in Singapore, they are looking at a lot of innovation. I think in future also we are having a lot of interesting solutions coming up. I think India also should look into it and adopt anything that can increase productivity and stuff. So I thought of sharing it for the betterment of the engineers in the group. Yeah, thank you for your time. Hope I was not fast, and you were able to understand something actually. So I'll wait for your questions. Yeah, that I'll hand it over to Sandeep.
Thank you very much, Diwakar. It was a fantastic presentation and a very interesting case study. Thank you for sharing innovation that Singapore is working for, and stuff that Singapore has done. So now, first of all, we will take a few questions. So maybe you can see the raised hands on your screen. So you could take the questions from audience one by one, and then we will go for the announcements. And thank you for ICE for joining us after the question answer session. So over to you, Diwakar.
I am not able to see the questions. Sorry.
So I will help you with moderating it. So the first hand that I see is from Akshay Pawar. So Akshay, could you shoot with your question, please?
Yeah, sure. Thank you, Diwakar, for the excellent presentation. I have a couple of questions for you.
Yeah.
First is, you mentioned about the vibrometer and vibration monitoring. So I want to ask that in Singapore, how do you arrive at the range of vibrations you are monitoring? I presume that they are very strict with the settlements or all. So what is the process to arrive at this range of vibration we have to monitor and above it? So how do you arrive at that range? That is my first question. And second is that you mentioned about the mixed phase conditions, which you frequently encounter there. So as a client, does your monitoring approach changes when you are expecting mixed phase condition? Or is there any specific data you look for when you are going through a potential mixed phase condition? These are my two questions.
Okay. For the vibration analysis, generally we, the criteria, we have a Singapore CDC requirement, and there they have certain guidelines. Even for the track twist and other particular things, there's already pre-existing, design guidelines that has been put across. So generally we follow that. And again, in our case, because these tunnels were the old tunnels, so the QPD in our case went to an extent to do an further check on the structure and the how bad it is, or how it is whether leaking or thing. Then they went and added a further analysis to say that we must be more stringent within the CDC, which is already been prescribed actually. So that is the base guidelines for the design in Singapore. It is not like they go and do and check how much vibration is coming, nothing like that. There are some guidelines, and based on that they follow it actually. So we use that as a base, then based on that we evolve according to the site situation or project conditions actually. And coming to your second question on mixed phase, generally in the mixed phase, what we suggest the contractors is that before they start tunneling, we as being this is a built only contract, we had our own QPT, we did our own bore logs, and we estimated a rough location where the mixed phase is coming. But when the contractor is on board as a client, the first thing when we ask them is how will you mitigate the risk of mixed phase. Then we suggest them that they go and do their own soil investigation, maybe inclined. So in our case, we suggested the contractor to do some inclined investigations to exactly find the location where the ground is changing from one location to another location. So again, if the contractor takes his decision whether he wants to take up that risk. Here also we had some surface obstructions which we could not because of the EWL there, we could not do any incline. But if at all any other locations we are going to, we generally ask the contractor to make sure they know exactly at which chainage they are going to go into mixed phase condition actually. So that is one way. And other way is from the soil coming out from your excavation chamber, like what I told. You could see in my case there was a brown Jurong formation and a gray Bukit Timah granite. So you can immediately when the soil is coming out, if you take a scoop from the bucket and you just wash it, you can find out what type of stone you've got. So then you can tell easily that you've moved. So in an everyday basis, our contractors give us a report of what is the soil color or the ground condition. So if we find at one stage we are changing from one ground to another ground, then immediately we tell the design consultant and they look into and see whether the phase pressure has, because when you're going from a soft ground to hard ground, you don't have to have a high phase pressure. It is going to damage your tools. So we reduce our phase pressure. So that is how we manage a mixed phase condition when you're mining in this case. For example, if you are going in the soft case which I told, again there is OA is usually in Singapore is a color, a brown color. When you go into marine clay, it's more gray blackish color. So immediately you can find a change in color when you enter a mixed phase. Good thing about transiting in a soft ground mixed condition is that you don't have to worry about the tool wear, and you can see the increase in penetration rates in your TBM, because as I told, in Kalang you will mine faster. With the same thrust force you will be getting a better penetration rate. So that is how we judge, okay, we entered into a mixed phase. This is all based on my experience handling this mixed phase situations actually. So hope this was some of given you some info on what you asked.
Yeah, sure. Thank you, Diwakar.
Our next question is from, if I am not wrong, if I am reading the name right, it is from C. Bhimanvar. Could you please go ahead with your question?
Yes, sir. I am Chidanand from Tata Consulting Engineers.
Yeah.
We are currently consulting some of the sewer tunnels for MCGM in Mumbai, sir.
Okay.
And I hope tunneling in Singapore is same as the tunneling in Mumbai when the space concerned. When the space is concerned.
Okay.
I mean space constraint is concerned. So I have in this regard, I have two questions, sir. One is in some of the sections, we are going very close to the metro piles, and that is less than 1 meter.
Okay.
And is there any thumb rules to decide the minimum clearance between pile edge and tunnel edge? This is my first question, sir. And second question is, what type of TB machines shall be used? Hello.
Hello, yeah, okay.
No, it was a bit noisy. Okay. Okay, my second question is, sir, what type of TBM machine shall be used in Mumbai geology,
Okay.
which varies from weathered to hard basalt below 15 meters? Because we are doing two projects, sir. One of the contractor has came with EPB machine, and in other project he has come up with slurry machines. But the strata is almost same, like weathered to hard basalt below 15-meter grade. Meters. So
Okay.
this is okay.
For your first question on what is the gauge between TBM and pile clearance, again we cannot tell that if you are 1 meter apart it is very close, because I think you can mine, because you will not, unless you deviate your TBM mining very badly, then you go and hit the pile. But it's always good to check that your pile is exactly 1 meter clearance. To make sure it is correct, you have to ask somebody to do a cross check of the pile depth by either seismic or any method that can allow you to find out exact depth. If at all, then also if you find you're going to encounter, you must also be prepared for that. It's always better, we always estimate 1 diameter clearance. That is what we put up in a requirement, that when the TBM alignment is being fixed, we tell that all the pile must be 1D cleared away from the tunnel alignment. So before we, like for example, our future lines, we make sure that the alignment is diving such that we are below 1 diameter. So for example, a 7 meter means we go below 7 meter. 1 meter is really close. Maybe the face pressure itself could impact the piles actually. So it's very important how they manage the excavation when they're going there. So there's no guide in Singapore. We have this guide. If we are very less than 1D, then we have to be very careful, and the contractor must be prepared that in case they go and hit the pile, they must have enough of precaution to go inside the cutter head and cut and remove and stuff like that. But we generally don't allow. If we find that we are encroaching a pile, we will remove it. If we cannot remove it, then we dive as much as below we can go. That is what we, in Singapore's context, that is being done. I am totally not totally into Indian thing. Maybe through TAIym I'm trying to understand how Indian tunneling is going to work, so I will take some time to understand. And for your second question on the basalt thing, if you say it's a weathered rock, like in my case, you could have seen that I was transiting from a weather rock to a full face rock. So if you say it is a EPB is still okay to be mined, but you must be you must understand that EPB is a better way of managing slurry. There's a lot of difficulty when you're managing this slurry circuit system. You need a STP and stuff. So many contractors generally prefer to go EPB if the conditions is weathered and still can be broken by the disc cutters. So when you're mining through this weathered rock, and if you can break and you don't have a problem of changing your cutter tools, again it depends on how long is your full face rock. If it is very long, then you have to look at other means. If it is a very short, in my case it was a short stretch, majority of a portion was in soft weathered rock, so we choose an EPB, and then we had to mine the remaining stretch with the caution of frequent CHIs to ensure the discs are able to break through, and with some polymer conditioning that could help the disc cutter break to maybe 2-3 rings more. In that way we managed and completed the tunnel actually. So it really depends on the strength of the rock actually. So that will be the deciding factor.
Means, I mean, if strength is more, then we can go for it, slurry, like that you are telling.
Yes, slurry, yes. Strength is more, and you have to go for slurry. Yeah. Or then if it is very big, then they'll go for open face. I think don't need a slurry also. I don't know how is the strength of basalt over there. So I'm telling, if it is a very good rock, then usually is open face TBM. If it is between in between that and with any sensitive structure above, it is better to go with the slurry mode so that you can manage the ground excavation, so that you don't cause a cavity or something suddenly. Yeah.
Sir, I have one more question actually.
Yeah.
Hello. Sir, actually, in our tender, we have mentioned EPDM gaskets for the segmental tunnel, and we are doing sewer tunnels.
Okay.
And also, I have heard that EPDM tunnel, the EPDM gaskets will get affected. Means will torn out, or its strength will decrease because of jacking thrust.
Okay.
So is that no, in our tender we have mentioned EPDM, but some are suggesting that to go for SFRC segments. So what is your take on this?
You're talking about gasket and you're talking about segment. So these are two different issues, I guess. So SFRC is a segment without rebar. Even in SFRC, you have to put EPDM gaskets, because gasket is generally to prevent water coming into the tunnel generally. So if you say damaging because of thrust jack, then you have to, that means the operational wise there is some problem, or the segment, the face where the thrust jack comes in contact, you must properly manage it. So generally in Singapore, we noted that when you have a single shoe thrust jack, means we have one thrust cylinder holding a jack, then the jack tend to rotate. If you can understand what I'm trying to say, that's why they go with a double jack. Means there'll be two jacking frame attached to one single thrust jack shoe. So then the rotation of the jack shoe is very less. So it will be in proper contact with the segment when you are pushing it further. So that is one way you can mitigate the cracks or gasket getting damaged. I don't have a picture to show. Maybe if you can understand what.
In Singapore, you are using EPDM gaskets, or is EPDM gaskets, or what?
Yeah, EPDM.
And what about the segments, sir? As normal segments or SFRC?
Till today, we have been using both, but future all the contracts will be using SFRC.
Okay.
Yeah.
Now, what is the benefit, sir? What is the difference between using normal segments and SFRC?
SFRC, the rebar is not there, right? So, and also the production is much better. And here they have noted that SFRC's performance is much better than the normal rebar segments actually. And cost wise and productivity is also much better in terms of that. Cracks are also very minimum. So they are going for SFRC. Yes.
Okay, sir. Thanks a lot, sir. Your presentation was very good, very informative, sir. Thank you.
The next question we have is from Anshul. Anshul, could you go ahead with your question, please?
Yeah, thank you, Sandeep. Thank you, sir, for the wonderful presentation. My question is on Tbm dismantling part. Although you have given a brief intro in the innovation slide that how the unsupported section from the shield near the shield portion is being taken care of. So my question is like, although you have mentioned that when like geology in the coast area is like mostly of the rock formation, whereas near to the coast it is more of kelong formation. So how differently the support is being taken care? Because when there is a rock, I assume still there is some stand-up time, so you may able to remove the shield and support the section. But in case of alluvium or kolang formation, it is difficult to just keep it unsupported and then later on you can do it.
Yeah, I understand your question. Actually, it was too long, so I removed the 2 slides on that. Usually, what happens is when we are in soft ground, right, we have a criteria that we put it in the specifications that we need 1 TBM length plus 2 meter of, 1 ring of grout block. So before launching the TBM as well as at the receiving shaft, depending on the ground, we ask the contractor to do effective ground block. So that means you are not typically in OA or soft ground. You have made the ground strengthened, and they have certain parameters that the water permeability should be so and so, and the strength should be so and so, that is being specified by the consultants. And the contractor, before launching and also before the TBM comes to the station and end, they have to have a grout block there, because obviously it is very dangerous to leave an open face, because you mine fully with the face pressure and suddenly you lose it off, it's going to fall apart. So I didn't show that, it's my mistake. Actually, there is a grout block always at the end and the start of the tunnel. And the grout block dimension, we have a gauge is 1 TBM length plus 1 ring. So,
Okay, so yeah.
when TBM goes, it goes and docks inside this grout block.
And in case, sir, if it is rock formation, I mean, although it cannot be a grout block in this case, but there is any sort of support thing you like probably given as a requirement.
Yeah, that's what. So when you're in a rock, right? And in my drawing, you would have seen that we would have removed only the inner parts of the TBM, whereas we will leave the shield there. So we call it as a sacrificial shield. So the open location will be only the bulkhead location. The cutter head and the bulkhead, there will be certain distance, right? That will be the open place. And what we tell the contractor is, when we dock, we tell that the TBM shield must go inside the D wall by certain mm. So when you mine the for example, if the D wall is 1.2 meters thick, we ask the TBM and from the cutter head face till the shield is say about 1 meter, or maybe 400-500 then we mine inside the D wall of the station, and we ensure that the shield is penetrated 200 into the D wall. Then only we stop. In case we stop before the D wall, then we have a proper slurry wall that we put in. It is a big area to be explained. We have a lot. I didn't share all that. So for example, if we cannot go into the station D wall, then we put extra D wall panels, but it will not be with rebar. It will be fully with the grade 20, grade 10 concrete. That's it. We just grab, we put concrete, and then the TBM, we will ensure that the shield is penetrated into it by 200-300 Then we start dismantling. So we know that we are full face rock in front.
Yeah, understood, sir. Thank you very much, sir. This is something very innovative, or I should say unheard of, the technology in India, I think, as on date. Will surely may help in future.
Yeah, this is very common in Singapore, because in no place, in no project, we will be able to break into the station. One thing is, the location where we are breaking into the station is an adjacent contractor. Then there is a contractual issues that we have to face, and sometimes they wouldn't have excavated to the track level by the time our TBMs go there. So in most of the cases, we stop behind the D wall, or into the D wall certain level, and then we pull back the whole TBM into the tunnel. So that is one big challenge that we do it on a regular basis. I think you can say 80% of the project we do like that.
Okay, thank you, sir.
The next question is from Mr. Bala Subramanian. Could you please ask Diwakar?
Thank you, Mr. Diwakar, for the excellent presentation.
Yes.
Myself, Bala Subramanian, and the IC representative for Chennai chapter and working with Lasan to Grow.
Okay.
I have a couple of questions. One is, what was your experience in managing the dewatering, especially considering Singapore geology? And what was your longest period of stoppage of TBM when you were going to the granite type of geology?
What was the first question, sir?
Regarding your dewatering experience, how was it?
dewatering experience in terms of inside the cutter head, is it?
Yes, inside once you enter into the tunnel.
Okay, the dewatering, I think when we go into the cutter head, generally you have a face pressure that pushes away the water in front. So when you lower the face pressure, because you want to send your workers in free air so that they can quickly change the job. So generally when you lower the pressure, you, depending on the ground, you will have water seeping through the so-called face. So it is very minimum. We have not experienced very gushing water or something like that. And certain locations they have experienced, but I have not worked in that. But usually when we do a cutter intervention, we lower the pressure. Then we ask the worker to go inside, look into the face to see how much is the water coming. So maybe if it is flowing or seeping, so we do a cutter face mapping. So the face mapping will be done. In that they will tell, okay, at this pressure we are having this much. Okay, let's go down to 0 bar. Then they will see how much water is coming. If the water is coming more, then we will close the whole thing and we will not do any CHI, because we don't want to draw down water and cause settlement on top. So that is the way the dewatering is measured by the flow per minute. That's it. Because from the cutter head they will put a pipe or something to just see how much level of water is filling in the cutter head from the bottom. So they will roughly gauge what is the level of increase, and then they will estimate the water flow inside the thing. That's why I told we need a water stand pipe near a cutter head intervention location. But we really don't know where we are going to do a cutter head location, so it's very difficult to put a water stand pipe there. But if you have planned interventions, it's better to put a standpipe and you can measure exactly what water level is dropped and how is it affecting the surface. So that is one way. And on your second question, how long you've stopped in a granite? If you say if I'm mining through a granite, I didn't stop for long, because when you are mining granite, you're in a good phase. So you don't have to worry about lowering of phase pressure to 0. And mostly the problem with when you're mining in hard rock is you will have a lot of tool damage. So the time taken to change all the tools is the longest stoppage, I can say. Maybe depending on the productivity of the workers, maybe effectively one day they can change day and night about 8 to 9 tools. If you have 46 discs, then you can imagine how many days, maybe 4 to 5 days in a good phase, good condition and 0 bar pressure. You can just do a CHI for 4-5 days. Hello?
Hello?
Yeah, is it okay, sir?
Yeah, fine, sir. Thank you. Nice of you. Very good presentation.
Thank you.
Our next question is from Mr. Harvinder Rana. Harvinder, could you shoot your question to Diwakar, please?
Yeah, thank you, Sandeep. Diwakar, thank you for the presentation.
Yeah.
My question is from case study number 2, when you were tunneling in Khalang Formation.
Yeah.
So you had mentioned about injection of the bentonite from the slurry from the shield, right?
Yes, yes.
So does it help in reducing the volume loss?
Yeah.
And if it does, then you were getting, like you had shown, that you're getting volume losses up to 2 to 3%. I mean, it's comparatively high if you see the structures on top of you. I mean, you may be having settlements up to 20 to 30 millimeters. I'm assuming. So, I mean, was there anything you correlated, like still after insertion of the bentonite and you're getting higher volume losses? I mean, any specific reasons for these higher volume losses?
Okay, one thing what we noted is that when that particular location which I shared was, we were going in a mixed zone, right? So we were increasing the phase pressure from a lower thing to higher. One thing to note is usually when we are under a building and in a soft ground, the pressure the consultants give are quite on a conservative side. So basically, you note that when the Tbm is mining, you heave a little bit. Then after when you're approaching a particular instrumentation, you can see a slight heave in your readings. Then once you pass that instrumentation, you can find a sudden steep drop. That is because of the phase pressure, and that is one reason you can imagine the ground being expanded and then contracted, causing the settlements to happen. The concept of what we put the bentonite around the shield is to try and minimize this. Actually, the volume loss there could have been more. I have not tried mining without a bentonite there, so I cannot say whether it would have gone more. But effectively, when we put, you would have seen in one of my slides, we had a phase pressure sensor on the top also. So that is exactly for this kind of kalang formations, because we want to see what ground is coming onto the top of the TBM. That's why we put a sensor on top. So basically, if you have this kind of kalang formation which squeezes in, it is not a squeezing rock, but it comes in contact, you can find the phase pressure increasing. But we have some instrumentation results on the surface of phase pressure on top which has not showed much of movements. So I would say that the settlements that had happened is a nature of kalang formation to have that settlement. You cannot avoid that. And but if it would have gone bad, then it would have been a problem of what we have done in the mining actually. So I would rather say that this is one conservative approach to avoid any ground to relax. Because you can imagine, if you don't pump in a bentonite, if the clay can come down of the overcut, after you cut it can come and close your TBM, then that much amount of thing is already displaced. And that is why we in our requirements design, they say in kalang you will expect a 3% volume loss, but we achieved about 1.5 to 2%. So it's still 1% lesser than what it has been predicted based on experience from previous contracts.
All right, great. Just another one quickly.
Yeah.
What was the consumption of the annular grout for these particular locations?
Yeah, again, this annular grout thing depends on how much is the overcut of your TBM. So in my case was about 4.5 liters or something like that, because you need to estimate your perimeter of the overcut in terms of one ring. Then you can estimate the grout, right? So what we generally say to our grout operators or the contractors when they mine, we have this criteria that grouting plus we based on two criteria. Either they should achieve the grouting by volume or by pressure. So if either way they can they achieve, then we say they've done effective grouting at the back. So if you ask me in terms of what is the volume, it really depends on site to site based on the TBM overcut. But if you ask me what is the criteria for grouting to make sure you have done a proper, then you should go by two way. One is either by pressure or either by volume. So if you are not able to achieve by volume, then you try to inject as much as pressure, maybe your phase pressure plus 0.5 bar, because if you inject less pressure, already you have a phase pressure in front, right? So it will just flow, it will not go. You have to inject a higher pressure. So we give a criteria of phase pressure plus 0.5 bar, so that the grout can go into penetrate well. And if you achieve the volume, then we stop at whatever pressure it has gone actually.
All right, great. Thank you for the wonderful presentation.
Yeah, thanks.
Our next question is from Mr. Brajesh. Brajesh, could you go ahead and ask your query?
Sure, sir. Thank you. First of all, I would like to thank Mr. Diwakar for such a wonderful presentation. Sir, I have one question regarding when the TBM is encountered during the encounter. Hello? Is my voice audible, sir?
Rajesh, maybe it could be better because we are getting background audio when you're speaking. So is it possible to speak from a place where we could not have that background audio?
Sir, is it all okay now?
It's the same. It's the same.
So I will just first I'll ask the question first. So my question was, when the TBM is encountered at the underground station, so there is a very stress zone generated at the junction of this that's underground station and the tunnel. So what kind of support system have you provided in the in your studies, sir, in your project? Hello.
Hello, Diwakar. Hello.
Hello.
I think Diwakar has had some technical issues, and so what I'll do is I will share his email ID with all the attendants. If they have any question, they can directly email him their questions, and he will be happy to respond. So before we close, I would like to thank Diwakar, but I would actually drop him a message later on now. And thank you everyone for being with us today for this wonderful presentation. And ICE has collaborated with TAIym, and there has been fantastic audience today with many interesting questions, which in turn has shown that the topic of presentation was of interest to them, and it has really given us an insight of what we can do to improve in the Indian tunneling industry. Uh, and ICE has is trying to collaborate with TAIym on a permanent basis. So we will be having such webinars quite frequently in future. Thank you. Thank you to the organizer from ICE. And now be I'll be sharing some announcements for the upcoming TAIym events. So the next webinar we have is from a very experienced person who is a very keen tunneling professional and is actively involved with development of tunneling industry. We have this webinar on 24th of July 2020. Dr.
Sandeep, just to interrupt, sorry, Diwakar has joined again.
Yeah. Sorry.
Yeah, yes. I think I'll pause for a bit, and I'll give Diwakar the mic to answer a few more questions. So, Brajesh, could you go on and ask your question again?
Sure, sir. Thank you. Sir, I have one question regarding this project you are undertaking. So, while construction, as you mentioned, that the TBMs are not allowed to pass through the underground station. So, at this junction between the tunnel and the underground station, so there is a very variation in the stress zone. So, what kind of support system have you provided in your case? And also, there might be a certain change in the water flow also. So, how you encountered that situation in your case, sir? Thank you.
Thanks, Bridget. Like what I said before, that zone, right? We asked the contractors to do a grout block. So grout block is a kind of ground. You're grouting the whole ground over there, either by TAM or your JGP or whatever it is, depending on the ground. So already you are taking care of all your stress and other factors over there. So it is no more a ground that is you have to worry about. And as I told before, for water, the water coming there, that's why we tell that whatever grouting that's being done there, they have to test after the grouting is done to show that the permeability is not so and so at certain level as for what the designers have mentioned. So they have to do core samples of the grouting that they have done at that zone to prove that it is watertight. So we will not have any issue when we go there actually. So that is how we prevent this risk of water ingress or any collapse over there actually.
Thank you very much.
Thanks.
I think we have one more question from
Yes, sir.
Manavar, could you
Sir,
please?
actually, I have a general question. In your tunnels in Singapore, are you providing any secondary wall around inside the precast segment ring?
No, nothing like that.
Nothing is there. Okay, sir. Okay, sir. Thank you, sir.
Yeah.
Good evening, Sandeep. Good evening, Sandeep. This is Kriti Kumar. I would like to ask one question. I joined in from guest option.
Hi, Kriti. So I will. I think Harsha raised the hand before, so I will give Harsha the chance to speak first, and then we will come back to you.
Okay.
Yeah, Harsha, could you go and ask your question, please?
Yeah, thank you, sir. Thank you. It's a great presentation from Mr. Diwakar, sir. So actually, my question is an addition to Bentonite question. So is there any specifications regarding to the usage of Bentonite in underground excavation? And one more thing is the usage of Bentonite helpful in all types of squeezing grounds? And will it be more helpful with regards to volume loss? So you already explained with regards to volume loss. So with regard to displacement, is it more helpful in case of squeezing grounds?
Yeah, actually, thanks. Bentonite, it's not necessarily need to be bentonite. We also use the product called clay shock. So the main aim, what that you have to look into is, maybe the contractor can come up with anything else also. So far in Singapore, we have been using bentonite and clay shock. So clay shock is also a similar product like bentonite. Main aim is you have to have some medium that can be around that can fill the overcut area so that your ground does not come down. So that is the only thing which we have to take care. If you imagine, if you put a grouting over there, then you are going to catch a whole TBM again. So some people they would do that, but we don't recommend that, putting a grout over there. Generally we tell bentonite and clay shock. And this too also, when you pump in your backfill grout, can be easily displaced. Means when this is displaced, it comes into the front of the cutter wheel, and then we take it out of the screw. So that is how this is being worked out. And one more thing you must understand also is, whatever you pump in that overcut, you must also ensure that it does not contaminate the grout that you're pumping behind the TBM. We had one instances where some water or something, which it's not because of bentonite. We had some other water from the ground that went and contaminated the grout, and we didn't have an effective grouting. So also it can be a case of what you're pumping, like this bentonite. If they must not interact with the grout and cause some weak grout or something behind, then that will be a future problem for you. So so far bentonite and clay shock have been doing well. So I don't know about any other products. If I know, then I'll definitely share, but that is the main thing.
Yeah, thank you for that. And so it means it is very much helpful in all types of squeezing grounds, I guess. So
it should be, because you're just covering that whole gap, right? Any ground it should be able to. But if you say you have a very heavy ground that is coming, some people, I think it can, if the ground is coming and pushing it into the front, then it is a problem. But so far we have not had any problem in that, actually. Using it in Singapore's geological condition, I think it should work in other grounds also.
Yeah, thanks for that. It's a wonderful presentation.
The next question is from Mr. Kriti. Mr. Kriti, could you ask your question to Diwakar, please?
Thank you, Sandeep. Diwakar sir, I would say it was an excellent presentation. You brief a lot of things which we were not aware about. My first question is that since I come from a hydraulic background, and I would like to know what regulations are prevalent for hydraulic oil to be used in TBM. Means how they select the oil to be used, the hydraulic oil to be used in TBM. Because in some countries I see they use fire resistant hydraulic oil in the TBM. Whereas in India I see mineral oils are being predominantly being used in TBM. So is there some regulation or is there some system requirement for TBM machines to select the hydraulic oil? That is my first question. And second question is, suppose we are making a tunnel below a river or a pond. As in India, we did here in Calcutta, in the just below the Ganges River of connecting Howrah to Calcutta, there was a metro tunnel being made. So there was some water seepage issue which came to know. So how you are doing waterproofing in such scenario? These are my two questions. Thank you.
For your first question, in Singapore, we say no to fire, no to fire anywhere in the tunnel. So even the TBM parts and everything are fire resistant. First thing, even the hydraulic oil we use HFDU, so which is fire resistant hydraulic oil. So it is mandatory in our specifications that the hydraulic oil must be fire resistant. They call it as HFDU. I don't recollect, but I'm not mechanical. But we have HFDU is a term that we use for the hydraulic oils. And hydraulic oils also we encounter some contaminations happening in certain TBMs because these hydraulic oils, when they keep continue circulating in your systems. We had one of a TBM breakdown because one of the contaminations had caused the oil to be totally not fit for mining actually. So we also ask the contractors to put in effective filters that can filter to the minimum particles that can cause contamination, because this hydraulic supports the main drive. So now recently some of the TBMs, the main drives have been power driven. So only hydraulics is used for jacks and for the one more thing is erector. So only these two generally the hydraulics now in operations. Of late TBM manufacturers are changing into power driven motor main drives, so that if you get a contaminated oil contaminating a main drive, then you're going to stop the TBM wherever it is. So it depends on contractor's choice. But as for your question on HFDU fire resistant, we ask them to use fire resistant oils. And for the second question about tunneling under river, actually, if you know that you're going, we went under a sea barrage where we went under the sea, but what we do is maybe if you feel that there is a high water pressure coming in front, generally you will know it when you're mining, because your phase pressure will increase if there is a water seepage into the mining TBM location. Or maybe when you take out when you take out the soil, if it's an EPB, when it's coming out from the screw, you can see the paste not thick enough, it will be very watery. So if you have a water pressure, the best thing is you do a probe, in front, and check, or you grout, in front before you start mining. That's the only thing. But I don't know how long are you crossing parallel or perpendicular. But for me, I'm just like, I've not gone through such an experience, so I cannot tell more. But if you say how you have to handle that, then it really depends on making sure your TBM is able to manage that risk. Like for example, you have double screw gates so that you can immediately lock the gate if there is water that is gushed into the cutter head. We also have a precaution here where we have double screw open gate, so we have double chamber with the two gates. So if one gate gets jammed or something, then we have another gate at the back that can lock and make sure the cutter head parts and whatever is in the cutter head is not flowing into the tunnel. So, and maybe also one other requirement for our TBMs for making sure we don't have any problem is that the screw conveyor at the bottom, we have a closing gate. So we ask the contractor to design something like within 30 seconds, you should be able to lock the screw in front. Means you extract out the screw and you can close the screw. So totally the cutter head is not in connection with the TBM itself. So whatever in front you have to deal, then go inside the cutter head, solve it, then start mining. So if you have any challenge, you have to play with play with the risk and how you have to design your TBM. That would be my suggestion.
Okay, okay. So hydraulic oil is HFDU. For approaching this HFDU oil to be used in a particular tunnel, should we approach the contractor or the TBM OEM?
No, in our case, we tell it is in our specs, so we don't. You contractor definitely will come and ask, but this oil is costlier than a normal hydraulic oil. Obviously, contractors would not prefer to use it. So it depends on the client who you are dealing with. If the client is persistent to have it, then contractor will use it. If not, then the contractor will go for obviously the cheaper solution.
So in the practice session, there is no harm with the equipment. It is only is there using of fire resistant is a requirement, or is it only because of the regulation there?
Here we have a requirement because we don't want to have a fire inside the tunnel. Because even if you see our locomotives also earlier was diesel loco, now we have totally converted to battery locos. So we don't want any sort of any risk of fire inside the tunnel. So that is the main reason we did a full. When I joined in Singapore 6 years back, my contract were still using diesel locomotives, but then they changed now to battery. So similarly, they changed this hydraulics oils also to be HFDU, and then make sure we don't have a totally zeroing the risk of fire inside the tunnel. So again, it goes to the client. Here, the client is very powerful. So they tell what we need and then they get it.
Okay, okay. Thank you, sir. Thank you.
We have one more question from Shweta. Shweta, could you please go ahead and ask your question?
Thank you, Sandeep. Thank you, Diwakar. Thanks a lot. I won't take a lot of time. I just wanted to add to this aspect of bentonite, what many are asking, this clay shock thing, when Diwakar mentioned, I just wanted to mention that you guys can see our webinar 3, where Russell discusses a lot about this clay shock, and it is an interesting aspect, and exactly how Diwakar has explained that. That's it, and thanks a lot, Diwakar.
Yeah, no problem. Okay, good to hear that somebody has spoken before. Yeah.
Yeah, that's true. We have our YouTube channel in the name of TAIym, and we upload all our webinars there after the event. And all those who are from ICE with us today may not be knowing about this, so they may visit the channel, and there are many interesting case studies and sharing of experiences on that YouTube channel. So I would like to quickly share the announcements, and because it's already too late in India and of course in Singapore as well, I will leave you for your dinner as soon as possible. So we have our next webinar from Dr. Cosimo from Spain, who will be speaking on design approaches to avoid problem solving during TBM tunnels execution. And this webinar is in collaboration with British Tunneling Society young members. And I will be in touch with Satish to see if ICE can collaborate on this, and we can share it with everyone as well. Then we have another webinar from Max, who will be presenting from Brazil. This will be on collapsible soil settlements controlled by grouting and preliminary results for expansion of Brazil subway system. On 28th August, we have a very experienced person who is an expert in dispute avoidance and resolution, and has been very active with FIDIC and will be introducing us with the new FIDIC ITA form of contracts for underground works, the Emerald book. Then we have our newsletter coming up, and we'll be sharing it quite soon. Hopefully, we'll be circulating it by next week. Then a little bit about World Tunnel Congress. The physical WTC 2020 has been cancelled this year, and it will go virtual. So there will be opportunities to present your papers and be a part of it online. If you want to reach us, do drop us an email on taiymyoung@gmail.com and be a member to contribute from your stories, and we welcome you as well to put your name forward if you have a good experience that you want to share. We have blogs, we have webinars through which we share our experiences, and we document them for our future and current generations. We are active on LinkedIn with almost 3,000 followers now, which I can proudly say that it is the highest among any other tunneling young member group across the world. And do visit our YouTube channel. It is very interesting. It has very interesting webinars and other videos as well. And do stay in touch. We will be bringing many more stories, interesting as from Diwakar today. And we'll be seeing you again. Thank you. Thank you very much. Thank you very much, Diwakar, for being here. And thank you very much for ICE as well to be a part of this. And and with this wonderful audience who has joined us. And Diwakar, we are very grateful to had you today here and speak about your experiences. It was a great effort to bring the two countries closer by sharing your experiences. What are the common things that we are doing, and what are the things that we can learn from each other? Thank you very much, Diwakar.
Yeah, sure, man. Thanks. Thanks, and thanks to the listeners as well. Yeah.
Thank you. Bye.
Thank you. Thank you.